Okay, so now after the refresh of your knowledge about the distributions, we are going to talk about, I believe, the most important part of the following presentation. We are going to talk about distributions fitting and model selection. So just briefly to remind you that we have discussed that the most powerful approach of how we are defining randomness is actually usage of theoretical distributions. But again, as we have discussed, usually we have a data, meaning that our task now is to find the distribution which describes our data. And this one is called distribution fitting. Okay, so let's do our first steps in the distribution fitting. This one is the most simple approach, which is based on analysis of a histogram. That's why it's called histogram method. Before going deeper inside and providing explanations regarding the following slide, I would like to pay your attention that in frame of our course we are going to utilize a piece of very simple software which is called StatFit. Again, very simple for understanding, but it makes its work really very effective. So you could download a software in frame of our course, just install it and start to use. So going back to a slide. So you could see a figure, you could see the diagram, and the blue bars represents the observed data, and the curves shows the different theoretical distributions fitted to the same data. So as you're able to see, here I have tried to fit exponential, log normal, normal, and uniform distribution. So just to repeat that our task is to identify which distributions best follows the shape of the histogram. In this example, I believe it's quite clear that only two distributions can be considered as the candidates. And just try to think for a while, and of course it's exponential distribution and log normal distribution. So of course it's quite clear that a uniform distribution and normal distribution are probably not the best to utilize in this case. Before moving to the next slide, it should be stated that a following approach is really very simple, but it shall be clear that right now I am demonstrating you, I would call it a training diagram. So mostly it's really very clear to see that out of 4, only 2 seams can be used to describe our data set. But here comes the question. Okay, we catch up. There are 2 distributions. But the question is how to make decision which one distribution I shall use in this case. It's a first question. The second question is, if you are doing research, if you are preparing your master thesis or PhD thesis, the question would be, what kind of arguments I could provide to the readers that I have selected a following specific distribution. To answer the last question, we must go even deeper inside and we must talk about something which is called statistical hypothesis testing. Again, I assume that during your bachelor study you had some experience with statistical hypothesis testing. So in this case, what we are going to do, we are going to test statistical hypotheses about the distribution. And for this purpose, we are going to utilize, or maybe we are not going to utilize, but it is recommended in the literature to utilize the following tests, like a Kolmogorov-Smirnov test, a chi-squared test, and Anderson-Darling test. So I'm not going to explore them in details here. I just presented you the titles, and I will demonstrate how to apply them from a practical point of view. But if you would like to enrich yourself with a specific test, I would like to pay your attention that here I have links, so read more. This one would bring you additional information about each specific test. So, as I have stated, we are not going deep inside the specific test, like a Kolmogorov-Smirnov test or whatever, but we are going to talk about the practical side. So, as I have stated, in frame of the course, we are going to utilize StatFit software, and the StatFit software is not only producing beautiful diagrams, but also can be used for statistical hypothesis testing. So pay attention to the following ugly table, I would state, which is produced by the StatFit. So this one is the overall result which we have received from the analysis. So let me briefly describe what we are able to see. So we are able to see the set of distributions: log normal, exponential, normal, uniform, and next one, and this one is really important, we see the column which is called acceptance. And here we are able to recognize two outcomes of the analysis: do not reject and reject. So do not reject here and reject is here. So what is a meaning, or what is a value of the following information? So StatFit completed a statistical hypothesis testing and provided us useful information that a uniform distribution and normal distribution should be rejected. So they not the best choice, let me say in the following way, to describe the data. While you are able to see that for two distributions which actually we catch up from visual analysis, log normal and exponential are marked as do not reject. So we need to consider. But here we are coming to a very important aspect. Okay, now it seems that we have two candidates. So log normal distribution and exponential distribution. How to select the best? So to be a bit formal, StatFit provides us two additional columns, rank and AICc probability, which can be utilized for a decision making. The most simple approach is to use the rank. As you are able to recognize, the higher is the rank, the higher is the probability that we need to select a following distribution. So, meaning that such a brief analysis already gives us a lot of information. But just to finalize the discussion, what I would like to mention that we didn't touch a following question before, but let me remind you that each distribution has parameters. And if we would like to describe randomness inside the model, we need to indicate not only the distribution, but also parameters of the distribution. And you see, here we are able to recognize a specific values for each distribution, which is the second very important result for us. Okay, so we have already quite a lot of useful information from StatFit, but for people who would like to go deeper inside and see how actually statistical hypothesis testing is working in a stat fit, in this case you could select the specific distribution and you can get much more useful information. So to check whatever a fitted distribution is acceptable, we use statistical hypothesis testing, as it has been indicated. A stat fit presents us the results of two tests, a Kolmogorov-Smirnov and Anderson-Darling tests. So with a significance level of 5%, a p-value above 5% means we do not reject the distribution. In this example, both tests give high p-values for exponential distribution. So it means that we do not reject the distribution. So it means acceptable fit. Therefore, the exponential distribution and of course log normal distribution, which is not indicated here, but you could verify, could be statistically consistent with the observed data. So the following slide concludes the topic which we have discussed. It represents a workflow for input modeling. And of course, a workflow which is represented here is a bit simplified. As you're able to see, it has a linear nature, but I believe it includes the most important stages of input modeling. So please pay attention that we are starting with data collection, so raw data collection. Next one, the stage which we have skipped, but this one is important. Of course, we need to clean the data, we need to process the data. Probably if we have identified the missing values, we need to do something with this one, or input errors, probably we need to check or recheck if it's correct or not, or maybe we have identified the outliers which needs additional analysis. The next step, which I would recommend to everyone before completing any kind of hypothesis testing, is to visualize the data. So just construct the histogram, try to get some descriptive statistics about the data set which you have collected. This one shall enrich you, and you should start to think which distribution, I mean theoretical distribution, would describe in the best way your data. Next one, when you have identified the candidates, you could go deeper and you could apply statistical hypothesis testing, or sometimes they refer as a goodness of fit tests. Next one, after completing the testing, you could choose a specific model, and in this case, on the word model, we are talking about the model of how we are describing the data. So simply speaking, the specific distribution. But what I would like to pay your attention, that as we have discussed, a modeling is some sort of art, meaning that you are not able just apply a specific algorithm and just follow the algorithm, meaning that we should always consider the domain logic. So as example, you have identified that a processing time can be described with a normal distribution. So, but it's quite clear that a processing time cannot be negative, as we have discussed. So just try to look what kind of output, at example, a StatFit software is providing to you. So yes, maybe it could be normal, but remember the normal distribution has parameters, 2 parameters. Just try to look a bit closer to them and try to catch what would be a probability that you will get a negative value and how you are going to solve this one. And finally, a validation against a real system behavior. So meaning that finding the specific distribution, it shouldn't be a goal of your analysis. Our final goal is actually to develop the reliable simulation model. And if you see that, at example, StatFit or any other software is saying, no, man, a following distribution fits well, but the overall system behavior is not correct. In this case, you need to start from the beginning. Try to see. Maybe you should utilize another candidate, maybe a parameters shall be adjusted.